Hey everyone, welcome back to my channel. Myself Aditi Sigowda, studying in Sri Venkateshwara College of Engineering from Department of Computer Science and Engineering, subject Mathematics, topics Applications of Polar Coordinates. So let's come to the introduction part of polar coordinates. The polar coordinate system is a two-dimensional coordinate system in which each point on a plane is determined by a distance from a reference point and an angle from a reference direction. The reference point, analogous to the origin of a Cartesian coordinate system, is called the pole, and the ray from the pole in the reference direction is the polar axis. The distance from the pole is called the radial coordinate, radial distance, or simply radius, and the angle is called the angular coordinate. Polar angles or azimuth angles in polar notations are generally expressed in their degrees or radians, 2 alpha rad being equal to 360 degrees. So let's know about what are the applications of polar coordinates. Polar coordinates offer a unique perspective on problems involving distance and angles. This guide will walk you through a rich exploration of polar coordinates, dissecting their fascinating applications across a myriad of fields, illustrating various complex problems and portraying their significance in mathematical and scientific disciplines. So let's know step-by-step guide to learn applications of polar coordinates. Here is a step-by-step guide to learn what are applications of polar coordinates. Step 1. Grasping the basics of polar coordinates. Being with a fundamental understanding of polar coordinates, discover how they differ from our coordinates and how to convert between these two coordinate systems. Acquaint yourself like concept of polar plot and understand how a point can be represented using a radius. Resources such as introductory calculus, textbooks, or online platforms like Effortlessness establishing this foundational knowledge. Step 2. Delving into the mathematics of polar coordinates. Polar coordinates are extremely useful in mathematics, especially in areas like calculus and complex numbers. Familiarize yourself with how to perform differentiation and integration in polar coordinates, offering a fresh perspective to those operations. Moreover, understanding how complex numbers can be expressed in a polar form will be beneficial when dealing with the functions of a complex variable. Step 3. Exploring the role of polar coordinates in physics. Polar coordinates find ample applications in the field of physics. For instance, in mechanics, they are used to simplify problems involving circular motion and angular momentum. Learn how to apply Newton's second law in polar coordinates, which can be especially useful when the problem involves a rotational symmetry. Moreover, into the world of electricity and magnetism, where the understanding and the magnetic fields often involves and use of polar coordinates. Step 4. Unveiling the applications in engineering. In engineering, disciplines like electrical and mechanical engineering, polar coordinates often simplify problem solving. For example, in control systems, the concept of root locus, which is often used to design controllers, is better visualized in a polar coordinates. In fluid dynamics, flow problems, especially those involving circular pipes or tanks, can be more straightforward to solve using polar coordinates. Step 5. Understanding the applications in computer graphics and robotics. Understand how polar coordinates can be used in a computer graphics for transformations like rotation, scaling, and sharing. In robotics, the represent of robot arm kinematics is often simplified using polar coordinates. The computer vision for operations like image rotation and finding the direction of a gradient's polar coordinates and invaluable. Step 6. Comprehending the use of polar coordinates in geography and navigation. Polar coordinates from the basics of geographic coordinate systems used to pinpoint locations on Earth. Understand how longitude and latitude can be seen as a type of polar coordinates. Additionally, in navigation, especially maritime and aviation, bearings are used to indicate directions, which is an application of polar coordinates. Step 7. Analyzing real-life examples. Study real-life examples where polar coordinates have been employed, such as in satellite navigation systems like GPS, radars, and sonars also use polar coordinates to detect the position and distance of the object. Step 8. Implementing your knowledge. Finally, put your understanding to the test by applying a polar coordinates in problem solving. Start with the simple converting Cartesian coordinates to polar coordinates and vice versa. Then proceed to solve calculus problems. You can also create simple graphic programs that use a transformation in polar coordinates. By following this step-by-step guide, you will gain a comprehensive understanding of the applications of polar coordinate that stretches across the vast landscape of mathematics, physics, engineering, and beyond, illuminating of the versatility of this robust mathematical tool. Of a graphical representation of a polar coordinates. So let's come to the graphical explanation. A visual representation of a data statistics based results using graphs, plots, and charts. This kind of representation is more effective in understanding and comparing data than seen in a tabular form. Graphical representation helps to qualify, sort, and present data in a method that is simple to understand for a larger audience. Graphs enable in studying the cause and effect relationship between two variables through both time series and frequency distribution. The data that is obtained from different surviving is infused into a graphical representation by the use of some symbols such as lines on a line graph, bars on a bar chart, or slides of a pie chart. This visual representation helps in a clarity, comparison, and understanding of numerical data. Graphical representation of data, it is an attractive method of showcasing numerical data that help in analyzing and representing quantitative data visually. A graph is a kind of chart where data are plotted as variables across a coordinate. It became easy to analyze the stand of change of one variable based on the change of other variables. Graphical representation that through different mediums such as lines, plots, diagrams, etc. Let us learn more about the interesting concept of graphical representation of data, the different types, and then examples. So let's know about a polar coordinate formula. We can write an infinite number of polar coordinates for one coordinate point using the formula. The value of theta is positive if measured counterclockwise. The value of theta is negative if measured clockwise. The value of r is positive if laid off at the terminal side of theta. The value of r is negative if laid off at the prolongation through the origin from the terminal side of theta. The side where the angle starts is called initial line side, and that ray where the measurement of the angle stops the terminal side. Cartesian to polar coordinates. X is equals to r cos theta, y is equals to r sin theta. So let's know about the how do we use applications of polar coordinates in real life. Useful application in physics and engineering. Explanation. From a physics point of view, polar coordinate tan theta are useful in calculating the equations of motion from a lot of mechanical systems. Quite often you have objects moving in circles and their dynamics can be determined using techniques called the Lagrange and the humulation of a system. Using polar coordinates in favor of Cartesian coordinates will simplify things very well. Hence, your derived equation will be neat and comprehensible. Besides mechanical systems, you can employ polar coordinates and extend it into a 3D spherical coordinates. This will help a lot in doing calculations on field. Example: electric field and magnetic field are temperature fields. In short, polar coordinates make calculating easier for physicists, and thanks to that we have better mechanics and better understanding on magnetism. essential for generating power. So, come to the conclusion. Angles in polar notations are generally expressed in either degrees or radians. 2 alpha rad being equal to 360 degree. Degrees are traditionally used in navigation, surviving and many applied disciplines, while radiations are more common in the mathematics and mathematical physics. The angle alpha is defined to start at 0 degree from a reference direction, and the increase for rotation is either a clockwise or counterclockwise orientation. For example, in mathematics the reference direction is usually drawn as a ray from the polar horizontally to the right, and the polar angle increase to positive angles for counterclockwise rotations, whereas in navigation bearing heading the 0 degree heading is drawn a vertical and the angle increases for clockwise rotations. The polar angles are towards negative values for rotations in the respective orientations. Thank you for watching my video. Please do like, share and subscribe my video. Thank you.